咁我哋個 differential equation 咧，in this form 啦嚇。And then you need to try to solve it, okay? To find the maximum height. Actually, you can ignore the question. You can try to solve this differential equation. Now we have some initial condition 咁呢個 initial velocity is u upwards. Sorry. 個 velocity 係 u 啦。And then 個 initial vertical height is 0啦。And then you go to maximum height 啦。At maximum 咧就 velocity is 0啦。Then you know how to solve this differential equation. How would you like to solve this differential equation? There's so many different ways to solve it. So then how will you solve it? Now we may use this question as a question to train your solve the differential equation skill. First of all, for the method 1, you can consider this is a differential equation of y dot. Then this is a separable equation. This is a separable differential equation. And then when you multiple k on both sides, and then you can integrate it. So on the left hand side, you get the natural log g plus ky dot. And then on right hand side, you get negative kt. But actually, I prefer you to do the integration. I prefer you to do the difference integral. So what does it mean? You need to input all the initial value in it. So initially, the velocity is u. And then the time is 0. And then we are not going to solve at the highest point only. So we want to get a more general form, then we need to substitute t as a time t here, and then this y dot. Let me highlight these two. Now these two are variables. It's so interesting actually. So the range of the integral can also be a variable. And then if solve it, if you input as a variable, then you get a more general form. Y dot u. And then you need to simplify on the left hand side, and then you get natural log g plus ky dot divided by g plus ku equal to negative kt. So we leave it here first, okay? Try to see another method to solve it. Actually, how to choose which method to solve it, it depends on what you want to get. So for the first one, you can see you can get a relation between the y dot and t. That means if you want to solve the velocity as time t, then you need to use the method 1. For method 2, if you still remember, last time I told you that if it's double dot, then you can write it in terms of this one.
Yes.
And this one can help you to solve the y dot as a function of y, or y as a function of y dot. G plus ky dot dy. Of course, you need to divide this one on the left hand side and then do the integral. This differential equation is a little bit more difficult to solve. Do you know how to solve the integral in the left hand side? Now let me substitute the range of this integral. Okay, how to solve the left hand side one? This one. maybe let me simplify the case. So let's say if you know how to solve this integral. Maybe let me put all those variable here. Okay, know how to solve this one. You need to use the partial fraction. Yeah? So
Oh,
yeah, partial fraction. So what I will do that, I multiple k on the numerator and the denominator. Kx here.
It's 6 o'clock.
So and then I can plus g and minus g on the numerator. So then this formula can be rewrite as this one. Right. This one. And then the next step that we need to use that. Okay, this you get the x already. And then here you need to multiple k first and then divide by k again. And then you get the natural log g plus kx here. So then you can substitute in this formula. Y dot minus u are so complicated. Sure. Actually, I'm not sure if I get it correct or not. I wonder if I get something wrong here. Yeah, maybe something like this. Now, actually, you cannot express y dot as a function of y because there's a natural log. The y dot, one y dot is inside the natural log. And then, but in this case, it's still fine because at the highest point, the y dot is 0. You can get the maximum height easily. So the maximum height, so you put y dot equal to 0. And then the minus sign can be cancelled out on both sides. So it should be u over k and then minus natural log gk plus u over g. I reverse the numerator inside the natural log. In B, to make it to be look more natural. Okay. Any question?
No question.
好啦，咁頂高溫啊，so we may need to check but the dimension is not consistent. It's not consistent because let me see. Here should be divided by k squared. I think I get divided by k squared.
Oh yeah.
Then it should be fine right now. Yeah. So and then so if you want to find the maximum height, you better use the method 2 for part 1. So and then for part 2, you want to find the speed and the time when it returns to original position. So actually, let's do the part 3 first. For part 3, if you want to find the time, of course, it's better for you to use the method 1 here. And then you can substitute the y dot equal to 0 and then get the time already. So, and then for the speed and the time when it returns to original position. So I need to clear the screen. I think I don't need to clear the screen.
Yeah. Sure.
So and what we should do for the downward motion, you need to change the variable a little bit. So the equation will becomes look like this one: y dot dot equal g minus ky dot.
Yes.
So if you don't need to solve the equation again. So what you need to do is replace the g by negative g. In the so and then you need to resolve the equation. You don't need to solve it again. But then you can't use this final solution now because the integral sign is different actually. So how we should replace the equation? How we can get the final equation? We can start it from here, okay? And then you need to change the range of the variable. So it's starting from 0 to y dot here. And then from this equation, so it should be no. Starting from here, it should be. The x has a range from 0 to y dot. From 0 to y dot. Just like this one. But you need to replace the g by negative g. Yeah. Then you get these two equations. Then you can find. You need to set the y to be equal to the same. When you go up and then go back to the ground, they have the same distance travel.
Yeah.
Then you can find the time when it return to original position. Yeah. So we can save the screen now, and then we go on to the next question.
Okay.
So if we change the question a little bit, just vary a little bit. If you make it to be v squared, the story is totally different. Okay. And let's see. There's another method to solve this equation actually. So let me write down the method 3.
It's like integrating factor.
Yeah, you can use integrating factor to solve it, but it seems it's quite complicated also.
Oh.
G here. Yeah. Okay. So we can use the integrating factor. You can try to solve it. Okay. So and then method 4, if you consider if you are solving it as an integrating factor, that means you are considering it as the first order differential equation.
Yes.
Then actually, this is a separable differential equation, so it's not too good to solve it with the integrating factor. Well, for method 4, you consider it as a second order differential equation. And then we can try to use that equation to solve. So how can we solve it? First of all, we need to solve the homogeneous parts.
Yes.
So we try the solution ERT. And you get R equal to negative K. Actually, that means that you get the, R equal to 0 or R equal to negative K. Two solutions. So then you can solve the homogeneous part easily. This one.
Hmm.
I'm not sure. Okay. And then for the particular solution, so what you need to choose that is you choose it to be a you choose it to be a so how many all so what is the order of polynomial that you need to choose there? First order, second order, or constant term? Now, if it is constant term, then of course the left hand side will not be equal to the right hand side.
Yeah. So.
So we like to choose the second order or the first order. Actually, it doesn't matter. You can just try the second order first. You can show that the A will be 0 afterwards.
Oh, okay.
Yeah. So actually, you can smarter way to do it. You try the first order. So the y dot you get is B, and y dot is 0.
Yes.
So you get y TB equal to negative G. So y will be negative G over K times X. So X means T, okay? Plus a constant here. That means that the general solution should be this one. Then you don't need to add a constant because they take it up together be a constant. Okay. Did we ever solve the y as a function of t in the previous solution? No. Yes. No.
As a function of t.
No.
Yeah, I think we did for
y dot as a function of t.
Actually, yeah, y dot.
What's the answer?
Let me just check.
So let me.
Oh, it's log g plus ky dot divided by g plus ku equals to negative kt.
Let me see. Let me see. Oh, the y dot. So we get this solution.
Yes.
So we need to express the y as a function of t. Y dot as a function of t. So you take the natural log on both sides. And then so complicated. And y dot will equal to g over k plus u times this one.
Yes.
Minus g over k. Yeah. Okay. So if you want to get the y as a function of t, what you need to do is integrate this solution. Integrate this one. And then integrate this function. And then you need to divide by 1 over k. And then plus negative g over k times t plus a constant. And you can see that these two solutions are actually quite similar.
Yeah.
Yeah, because just different by the constant. Because you haven't found this constant yet.
Yeah.
You want to find this constant, so what you should do to find this constant, so you substitute y t equals 0 and y equals 0. That means and then you get A plus B equal to 0. Okay?
Yes.
Okay. Yeah. And then you differentiate once. You differentiate once. Okay. Then you substitute T to 0, you get U here.
Yes.
Then you try to solve it, okay? And then you will get the answer. I think you'll get the same answer here. But you think if you look at the constant A, negative U plus G over K. Right. U plus G over K and then divide by negative K.
Yes.
So they are the same actually.
Yes.
Yeah. And then for B, okay, it doesn't matter. Now you can see that right now you have different methods, okay, 4 different methods to solve this equation. And all of them will give you the same answer. And then you need to try to do it again at home, okay? To see if you are familiar with these 4 different methods. If no question, then let's go on to this question. Now, if it's V squared, then the question is much more difficult. So how we should solve it? First of all, we write down the differential equation. It will look like this one.
Yes.
Alright, this one is easier to solve. And then we need to use this trick. Or you can say we must use this trick to solve it. So here you can simplify it. You can get this one. Or you can check it by using the like the product rule. Actually, if you put the dx dot on the left hand side, you can see why actually.
Yes.
Then this is a separable differential equation. If you want to get the answer, so it's from 0 to h2, and then the velocity will be from u to 0. Then you can get the height from this equation. And okay, so you can solve it by yourself now. This one. So no question. Okay. And then if no question, and then let's see if it is x dot cube. Okay. So if x dot cube, so you change the formula a little bit.
X.
Then the following equation are not applicable already, but you are still using the same trick here. And then you get x dot dx dot divided by g minus kx dot cube. Then what you should do là, you need to use the, let me do the question like this. Maybe let's do the question like this one. If you can solve this one, then you can solve this one. This is just different by the variable. Okay. So if you can solve this one, so how can we solve this one? You need to use the partial fraction. Okay. And you can minus 1 and plus 1 here. So what you get is -1 over this one. It will have the form like this one, but we don't waste time to solve it. You can solve it at home, partial fraction.
Yes. Okay.
And then you can solve both of them by using some trick. So we can ignore this question. Write down the expression only, okay? Actually, this one can't be solved easily. So you just write down the expression. If no question, then let's go on to the next one. Like this one. Or maybe I give you 5 minutes. You can try to solve it. You try to solve it. I can write down some step here. I should give you the initial velocity also. You let it to be VU. So if you want to find solve A as a function of x, so what you do, you just differentiate one. So no. Let me see how to do it. Actually, I may forget how to do it also. So let's say if we differentiate one, actually, if you differentiate one side, you can get the acceleration.
Yes.
But for force, you need to use a chain rule. For dv over dx, it should be negative n kxn plus 1. And then dx over dt is v. And then it will be the form like this one.
Oh, yeah, I see.
So let's have a look at how to solve it a as a function of t. Well, actually, we can solve the how we can solve this two. Actually, we can solve the x as a function of t first. Okay? So we can solve, actually, this is a separable differential equation. When you integrate it, okay, put from, it is not from 0. When t is 0, it's from x0, actually.
Mm.
And then integrate on both sides. Mm -hmm. Then you can express the x as a function of t now.
Mm.
Then if you differentiate one side, you can get the velocity as a function of t. If you differentiate twice, you can get the acceleration as function of a. Acceleration as function of t.
Mm.
Uh-huh. Hold on. I can save the screen now and then let's go on. This one. If we want to solve the sooner, you can solve it by yourself at home. Okay. So this one is actually that is quite similar to the question we done before, like this one, But this one is a projectile motion. This is actually a very special case. You can have a look at the solution. Now, solve it like considering the v as a vector without decomposing the component. So you can solve it like that, okay, and then you can get the answer. So this is a very special method to solve it. So actually, we don't have actually normally we don't solve the differential equation in vector form. Normally we solve it in component form, just like what we done before. So you can have a look at this question to see if you have any questions here. I think no question.
Why do you substitute specifically K over MT?
Where can you highlight that part?
Like this part. Like why do you specifically
Which one? This is integrating factor.
yeah. So like why like
So let me write down the equation in this form first. So like you multiple on both sides in integrating factor.
yes.
That these two can combine to get this form.
Yes.
So that means that d mu over dt equal to mu times k over n.
Oh yeah.
And that's how you get the integrating factor.
Mm. Okay.
So no problem. Then let's go on to next part.
Okay.
We have talked about this one already.
Mm.
And then try to see one of the question. We have done this one already. So let's have a look at this question, this one. So S is not a constant. So, and then
Mm.
S is not a constant, but you can express the answer in terms of S. Theta is this angle. First of all, what is the speed of the ship?
Uh is it V0 cosine theta?
No. If
Mm.
you still remember, there is a one constraint, or you can say the relation between velocity. Is a velocity along the string equals.
Mm.
So let's say if this has the velocity u
Yes.
then you decompose it along the warp direction.
Oh yeah. Mm.
Cosine theta equal to V naught. Okay.
Mm.
And then can you find the acceleration in this case? You try to do it by yourself. Mm. So how will you find the acceleration in this case?
You express secant theta as oh wait.
So what I will do you just differentiate once in this equation. But you get one term that is the theta of dt.
Mm-hmm.
Then how can you find the theta of dt in terms of theta or other variables? That is really a tricky part. Actually, we can do this question in many different ways. Now, if you still remember, we have learned about the velocity and acceleration in the polar coordinate form. So what I would like to do so first of all, let's see how we let the coordinate system. So I will let the origin at this point. Okay. And then that means this is the angle theta. And this has the length r. And then for r, theta head is along this direction.
Yes.
So if you express the velocity of the ship as in the polar coordinate form, then you will get that the velocity is along this direction. Or this is theta, this theta. Then you get u sine theta of theta head minus u cosine theta out head. Is it okay? You know how to get this answer. Now this is vector u, okay? This is the vector of the velocity, okay? And then the theta head is along this direction.
Yes.
This angle is 90 degrees minus theta. And this has the angle of theta here.
Oh, yeah. Okay.
Therefore, the components along the theta head is u sine theta. And then the component in the r head is u minus u cosine theta. Then we can substitute the general form here. R dot r head plus r theta dot theta head.
Yes.
So that means r theta dot that means equal to u sine theta.
Yes.
Then that means theta dot equal to u sine theta divided by r. Then r has the magnitude that is square root s squared plus h squared.
Yes.
Or if you express it in terms of theta, then that is h divided by sine theta. Then you can get your answer. Yeah, I know it's so complicated. And then u equal to v naught secant theta. So you get v naught square secant square theta divided by h times secant theta times tangent theta. Oh, sorry. Secant, and then times sine square theta. So if you express it in terms of sine, all the sine theta or cosine theta, you get sine cube theta divided by cosine to power 4 theta. Yeah. So that's the form of the acceleration. Of course, if you know that the acceleration can be written as this form. Then actually you can use this formula to find the r dot or r fair dot, whatever you want. Right? So we don't so we can use this formula to find the r dot dot. Okay? Because you know the r, you know the fair dot, you know this component. So we can use this form to find the r dot dot. And also can use this form to find the alpha theta dot. Yeah, you can get all what you want actually. So and then let's go on to find the tension. Okay, this I think it's not difficult. So for tension, it's just T cosine theta equal to MA. Okay. For the power input set, that means that the T tension times the velocity U times cosine theta, and you get the power.
Uh,
Any question?
no.
So then if no, then you can save the, okay, you have saved the screen now. Then let's go on to talk about the last one. So this one, actually, you need to, you can have a look at this question to see if you can solve the part A.
Oh, so two possible motions.
Mhm.
Okay.
Actually, if part one is possible, then part two is also possible. Right?
Mm.
So do you know how to solve it?
I don't know what I did wrong because I wrote this.
Uh,
And then like I tried to solve this equation.
yeah. So you get something, you get the idea, but you don't know how to solve it.
Yeah.
First of all, you know that the only forces are along the failhead direction.
Yes.
It's a non-version. Because there's no acceleration. Sorry, because there's no friction. That means r dot dot minus r failure dot square should be 0.
Uh,
This part should be 0. Actually, that's similar to what you get actually.
oh, okay.
It's r dot dot equal to r theta dot square, and then you know theta dot is equal to omega.
Yes.
And it's not r dot. I'm not sure if you get this one correct. And then you solve it, and then you try to solve this equation. This is a second order differential equation. And then you can just try the solution to be e alpha t, like this one. So you get alpha squared e alpha t that equal to O e alpha t times omega squared. Then you get alpha to be plus or minus omega. Then that's why the solution look like this one.
Oh yeah, I see. Yeah.
So then we have shown this one already, okay? So 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 we can try to do the part B. Part B is a little bit more mathematical. So you can see, so you can take some time to do it now. This question is totally mathematics, okay?
Okay.
Not physics. So let me clear the screen now. Okay.
Okay.
So
I still don't know how to
First of all, actually there's some condition here. First of all, if you when t to 0, then you get the initial position. That should be a plus b. This one should be greater than 0 by definition.
Yes.
So you get this first condition. And then the second condition, if you the r dot is always smaller than 0.
Yes.
That means r is always decreased. So what you need to do if you differentiate once
Oh
so
yeah.
this equation. And then of course you need to put it to be 0. Actually no, you don't need to put it, you can't put it be 0. But you can put it to be 0, but it doesn't mean anything. You just need to show that this is always 0, greater than 0, less than 0. So what you do you just try to rearrange the term. Omega can be cancelled out. And then you get A equal to B times C times 2 over T.
Yes.
So if this equation is always true, then how can you simplify it? But let's say okay, but the question doesn't say it. So let's say if this solution is always true, is true for all t.
Yes.
That means this one will go to infinity.
Yes.
And A, B have different sign. So,
Not necessarily.
not necessary, okay? So, yeah. So to solve it, and then you will, let me see. I get it wrong. It should be A greater than this one. I do the derivative wrongly, okay? When you solve it, okay, you get A greater than B times this one.
Oh sure, yeah.
It will go to infinity when t goes to infinity.
Yes.
So that means if A is a positive number and if A and B are all positive number, it is impossible. Okay. So that means.
Wait, but if you choose omega as you can, yeah. Can omega be negative?
No.
Oh.
Because in general, you can put omega to be positive.
Oh yeah.
It doesn't matter here. You get plus omega and minus omega. So and then that means B can both of them can't be positive. They can't be negative. Both of them can't be negative. Otherwise, A plus B will not be greater than 0. Okay? They can't be both negative. Otherwise, A plus B will be less than 0.
Yeah, so
So that means B should be negative.
oh yeah.
This equation is always true. So A should be greater than 0 than greater than B.
Mm.
And of course, and then A plus B still should be greater than 0. So if you choose this one, can we simplify this equation more? Let me think about it. That means is A will be greater than plus or minus B. Can we write it like that? No. Actually, you need to separate into two forms. Yeah. So if you want to simplify like this one, and then you say B is smaller than 0, okay? They're equivalent.
Yes.
Right? Doesn't matter, okay? So okay, we finish the part B, okay? Then okay, no question.
Yes.
I need to save the screen now. And then we go on to part C. So for part C that you are using this form, and then you see that you find the force exerted on the bit by the rod, and find the power, and also calculating the kinetic energy, and also differentiate the kinetic energy to find the rate of change of kinetic energy.
Mm.
So it may take some time to do it. So let me try to do some steps. So you get this form, then that means first of all, we need to find the acceleration. So and also the velocity. So for the velocity, you get it to be r dot r hat. Okay, r dot should be omega r,
R dot uh
r dot. Okay, r dot this one.
Differential. Okay, yeah.
When you differentiate R once, and then R fair dot. Fair dot, that means it's the omega.
Yes.
So you get this form. And then for the assertion, let me write it down first. There's R fair dot, R dot dot minus R fair dot square. R hat plus 2R dot fair dot plus R fair dot dot fair hat. So sad because you can only cancel out this form, this one. Only this one is 0. The
Uh,
other not 0. So for the first part, it's not difficult it's omega square
why is it 0?
because omega is a constant angle speed.
Oh, yeah, I see.
And then alpha dot square. So maybe let me express everything in terms of this one.
Wait, you said the R component is the acceleration is 0, right? Did you say that?
Yes.
Oh, okay.
Actually, we can show that this is 0 also here. Let's go to 0. Yeah. And then R dot fair dot, so complicated. Yeah. Oh, so easy.
Oh, so that one's the acceleration.
Mm-hmm. Okay. So you get the power, you get the force, okay? So how can you find the power?
Power is force times velocity, right?
Yeah, but you should remember you need to use the dot product. That means you need to take the velocity as in the direction of the force, or the force in the direction of velocity. So the force is along the fair head direction. That means the velocity you only need to take the direction along the fair head
Okay.
times the force. Let's try to simplify it. Omega cube times E times 2 to power omega t. Okay. Then for the kinetic energy, that's half mv squared. So for v squared, you have two components. So what you need to do, you need to use a Pythagoras theorem.
Okay. So
And then maybe we just differentiate first, okay, before we expand it. This should be 2r dot r dot dot, okay. Plus, you need to use the, fair dot is a constant.
yes. So okay.
R dot dot actually will equal to omega square r log. And you can show that these two will equal to each other.
Oh yeah, I see.
But this is obvious there because there's no energy dissipated in this system. The energy is conserved. Okay. If no question, then let's go on.
Okay.
Clear the screen now. So I clear the screen. Oh, we have talked about this one. Yeah, we have talked about this one already. But we haven't find the trajectory in this case.
Oh,
Now, it's not necessary to express the trajectory in the Cartesian form. So it's easier for us to express the trajectory in the polar form.
hmm.
The velocity is in this direction. So how can we do it? Yeah, we know that this is 30 degrees. That means the R dot is negative V times cosine 30 degrees.
Uh, yes.
Mm-hmm.
Is it always towards the center, like the component?
Yeah, because they always form a triangle by
Hmm.
symmetry. And then the velocity always has a 30-degree to with the R. And all the always somehow point towards the center
Hmm.
with a tangential component. So and then we need to try to solve the trajectory using these two equations. These are only two equations we can get here. It's much difficult to find the acceleration actually. And then we try to So alpha top divided by r dot should be equal to negative tangent 30 degree.
Yes.
Then it will this one will equal to r times the theta over the r.
Uh, yes.
The dt can be cancelled out.
Hmm.
Do you see why? You can always consider the ordinary differential as a fraction. Or if you multiply the denominator on the right hand side, you can see that this is only the train rule.
Oh, yeah, yeah. I see. I see.
So then you can get this one, and then of course it's better to convert it. So let me rewrite the formula. Okay. And then you integrate on both sides. So let's say the initial distance is r naught. Here is r, and from C to theta. Okay. Then
Okay.
you can get the trajectory in the polar form. Then I think it's not too difficult if you want to find the acceleration. So leave it. You can just use the general form to find the acceleration. Mhm. Okay. Now
Uh,
you can express everything in terms of R. Mhm. Now you can get the fair dot. You can get the fair dot in this form. You have get the R dot. R dot is a constant.
yes.
This one is 0. And fair dot is not a constant. So if you want to for R dot you get it, for fair dot you get it. So for this one you get it. And then for if you want to find the fair dot dot, you need to differentiate this one. This one.
Hmm.
but V sine 32 is a constant. So this one, you just need to use a train rule. Okay, then you can get the answer.
Okay.
Okay, then let's save the screen now. So this question is from the problem set in the training. So let me, okay, I'll give you the solution to have a look after the lesson. So now we have talked about everything about the all ODE and also kinematics that you need to know. Yeah. And then from next lesson we will talk about force and also talk about the force.
Sure.
Yeah, and then I hope we can finish talking about the mechanics in this month. Yeah, we need to start some thermodynamics from this month. So let me send you the note about the thermodynamics. It's written by me, handwriting by me. Okay, but it's a little bit difficult to understand actually.
喂，袁 Sir，打算同你講呢個。楊生你好啊。
係，hello，
爸爸嚟嘅。
好。